In this tutorial we're going to be creating a 2.5D sign within ArtCAM Insignia for this sawmill. This is going to be done by creating several different types of toolpaths. As you can see here, I've opened up the sawmill art file, and here we have the vectors being shown, and we also have in red all of the toolpaths that are shown. To hide these toolpaths, if I just zoom in, I can zoom in by using the middle mouse scroller. Here you can see all of the toolpaths in red. If I wanted to hide those, if you take a look on the top right of the project, and next to toolpaths there are various light bulbs. The light bulbs on the left are for the 2D view, and the light bulbs on the far right, which are solid, are for the 3D view. So we're just going to click on the light bulbs on the left, and that will toggle on or off the toolpaths visibility within the 2D view, and this just leaves us with the vector artwork that we're going to be using. If I go to the 3D view, here you can see the 3D view. I just clicked on the tab where it says 3D view, or you can select F3 and that will switch to the 3D view. In the project pane, we just saw the toolpaths here within the project pane, and what I'm going to do is just select the plus sign next to the toolpaths, and that will open up the toolpath tree, and it will show me all of the toolpaths that have been generated for this particular model. So what we're going to be doing for these is to simulate these, so it gives us a representation of what's going to be sent to the machine. And the way that we can do this, I'm going to do each one individually, is right click on area clear and then click simulate toolpath, and then just click simulate toolpath. Just rotated that around by pressing the middle mouse button and then moving the mouse around so it rotates dynamically. I'm going to right click on the beveled carving, simulate that toolpath. Right click on the V-bit carving, simulate that toolpath. Right click on the drilling and simulate that toolpath, and then finally right click on the profile and simulate that toolpath. So there you can see that we have our finished piece. Now if I wanted to change the material for this particular sign, let's say that I wanted a darker wood, what I could do is to select simulation, and then underneath material, at the moment it's set to light oak. What I could do is just select the arrow there, and it will open up this window, this flyout menu, and I'm going to change it to medium oak and apply. So there you can see that that's changed the material of the sign. Now what we're going to be doing is creating these toolpaths ourselves. So the first thing that we need to do is delete all of the toolpaths and also delete this simulation. So what I'm going to do is select the area clear and then right click and select delete, or select down here for delete toolpath. It's just asking me if I'm sure that I want to delete this, so yes. Do the same for the beveled carving, do the same for the V-bit carving, same for the drilling, and the same for the profile. Now to delete the simulation, if we right click on the simulation and then select delete, there you can see that leaves us with a completely blank 3D view. What I'm going to do is go back to the 2D view. So if you select that tab, or you can press F2, and we're going to select the reception text here. So there you can see that that's all in purple, so that's all grouped together. What we're going to do is delete that. So if you just press the delete key on the keyboard, that will delete the reception. Now I'm going to select the sawmill, and here you can see that this is grouped together also. So that's all in purple and it's grouped together. So I'm going to ungroup this. So the way that I can do that is press Ctrl U, or I can select up here under vector editing, hold the left mouse button down and then come down to ungroup, which does exactly the same thing. And there you can see that this is all in magenta, which means that they're all separate entities. So if I deselect that by clicking on the white area and then select the S, the W, the A, you can see that each vector is separate entities. So what we're going to do now is to create the toolpaths. And what I'm going to do is select all of the sawmill text, and I'm going to do that by selecting the S, and then I'm going to hold Shift down on the keyboard and select the outside of the A, the inside of the A, the W, the M, the I, the top of the I, and the two L's, and then I can let go of the Shift. So that's how you select multiple vectors in one go. You could also draw a box around this, but you risk selecting other entities. And now I'm going to group these together. So if I were to deselect this, I wouldn't have to select each one individually. So you can press Ctrl G, which will group them, or again go to this vector editing menu here, hold the mouse button down and select group this time. You can see that that's all turned into a purple colour. So if I deselect that now and select it again, you can see that the vectors are all grouped together. So if you select the toolpaths, if not already selected, that will open up all of the toolpaths available below the splitter bar on the bottom right hand side. What we're going to do is just press Shift and select the outside vector there, just because we want to create an area clearance in between all of the letters and the outside edge here. So the way that we do that is to click Create Area Clearance Toolpath. That will open up a new dialog box. We're going to do this over the selected vectors. The start depth is going to be 0. The allowance is going to be 0, because I'm not going to leave anything on here, and also the final tool allowance is going to be 0. Finish depth, let's do that 8mm deep, and make sure that your machine save Z and home position are set to 10. Just open up the arrow there and you can change the values there. For the tool list, I'm going to add a tool. So if I just click add, that opens up the tool database, and I'm going to add the largest tool that I have to machine all of the material away. So I'll click select for the 12mm end mill. I'm going to add another tool, so this does some leftover machining, so the areas where the cutter for the 12mm is too large to get in the corners, let's say for instance, let's say on this A in the centre there, a smaller cutter will go in and just machine that particular area. So I'm going to choose a 6mm end mill, and then I'm going to finally add a really small end mill just to clean up all of the little sharp edges. So I'm going to add a 1.5mm end mill. Now I'm going to just select the 12mm end mill, and here you can see just below here it gives me all of the parameters for this and the tool strategy that I want to use. And I'm just going to make sure that raster is selected, so it's going to machine in X and then step over in Y, go back in X, and the raster angle is set to 0 degrees. I'm going to select the 6mm tool now, just to take a look at those parameters, and this time instead of using raster I'm going to use offset. So what this is going to do is going to go round the profile and then offset inwards and then go round the profile again until it machines all of the material away. Make sure that the start point is set to inside, and I'm going to select the end mill 1.5, and I'm going to do that the same as the 12mm. So I'm going to use a raster with a 0° angle, so that looks fine. Make sure that the ramping moves is not selected. I'm going to set up my material, just move that so you can see. Set the material Z0 to the top and the model position in material to the top also. The material thickness is going to be 12mm, so OK that, and then I can click calculate now. So if I just close the 2D area clearance, just zoom in on this, here you can see the 12mm tool machining all around there. I've just highlighted that in blue. If I just zoom in, then you can see here this is the 6mm tool just going into the places where the 12mm couldn't get, and then finally the 1.5mm tool going into the places where the 6mm couldn't get. So I'm going to switch to the 3D view now. So select this tab or press F3 on the keyboard to switch to the 3D view. There you can see the toolpaths within the 3D view. If I wish to turn those off, just select the light bulb, toggles them on or off. And what I'm going to do is expand the area clear also. So that gives me my 3 tools, and what I'm going to do is just select the end mill, the 12mm one, and if I select here for simulation control bar, what this will do, it will allow me to play, pause, fast forward the tool, and it also gives me a representation of the tool here in a wireframe view. So if I press play, this will simulate the 12mm end mill. Now probably the quickest way of simulating these toolpaths is to select the 6mm end mill, right click and then simulate toolpath. That's simulated where the 6mm end mill is going to cut. Do the same for the 1.5mm, and there you can see that it's got right into the A, right into the corners here of the text. So now what we're going to do is to create the beveled carving toolpath. So create the prismatic letters for the sawmill. What we're going to do is switch back to the 2D view. So click the tab or press F2. Now as you can see at the moment there's all of these red toolpaths which are getting in the way. So I can turn those off by selecting the light bulbs on the left for the toolpaths. I can also close the area clearance now, as all those tools are just getting in the way and cluttering up the screen. If you have your vectors still selected, just select anywhere on the screen, it will deselect the vectors. What we're going to do now is just select the sawmill text and make sure that you select toolpaths under the project tree, just to go back to all of your toolpaths, and then select the create beveled carving toolpath. This will open up a new dialog box. Make sure that the vector association is set to selected vectors. The start depth is going to be 0, the wall height is also going to be 0, and the finish depth is going to be 7. So this is actually going to leave 1mm on the bottom because the area clearance was 8mm deep. I'm not going to change the allowance or the tolerance. The machine safe Z and home position should already be set to 10. I'm going to select a carving tool, and I'm going to choose a 32mm 130° V-bit and select that there. Now if I wish to see the maximum width and height, just click centerline here and it will show me that. and the material should already be set up, so I'm just going to click calculate, and there you can see that that's given me a preview of the prismatic letters. So I can close the bevel carving down now. If I go to the 3D view and right click on the bevel carving and then simulate the toolpath, this will give me a simulation of what's going to be machined. So now what we're going to do is to create some additional vector text for the reception part that we deleted. So if we go back to the 2D view, I'm just going to turn off all of these toolpaths here, just so they don't get in the way. And on the far left hand side, here we have create vector text. So I'm going to click that, and on the right hand side, it opens up the text tool. Now here you can see all of the fonts that are available to ArtCAM. Now these are all the fonts that are installed within my Windows folder, so every system font that you have on there will be shown within ArtCAM and you can use them. I'm just going to use Arial, script Western, size 25mm, and I'm going to make sure that it's bold and it's aligned on the left. I'm also going to add some spacing for the characters, which is 20%, and I'm just going to click anywhere on the screen and I'm going to type in reception, like so, and then click done to accept that. Now you can see that all of this text is grouped together. Now what I need to do is to align these. So the way that I'm going to do this is to press shift on the keyboard while the reception is still selected, just so it highlights the outside edge of the whole of the sign. And then whilst that is selected, if I come up to here where it says center in model, left click and hold the mouse button down so it brings a flyout menu out, and I'm going to align this horizontally. So that's place that reception in the center of this outside edge of the sawmill. Now it's not in the right position vertically, but what I'm going to do is just deselect all of the vectors, reselect the reception, and I'm just going to move this down by using the arrow key on the keyboard. So I can move that down or up using the arrow keys, and I can do this left and right if I wished. I'm just going to move it down to, let's say, about there, just so it looks right, and I'm going to deselect it so this reception is in the right position now. So what we're going to do is create some VBit carving for this reception now. So if we go to the Toolpaths within the project tree and select create VBit carving toolpath, which will open up a new dialog box for the VBit carving. Now at the moment you can see that I've not selected anything, so I need to select the reception. The start depth is going to be 0. The limit tool to maximum depth, make sure that that's not selected, and the tolerance is fine at 0.01. Going to select a carving tool. Going to use a 32mm 90° VBit, select that. If you wanted to know the depth, just click refresh. It's going to go in 3mm, and the safe Z and material thickness should already be set up, so I'm just going to click calculate now. Now if I close that, go back to the 3D view, and I'm going to right click on VBit carving and I'm going to simulate that. So that gives me a simulation of what's going to be machined. Now we're going to create the drilling toolpath. So we're going to drill 2 holes for fixing the sign to a wall. So go back to the 2D view. Here you can see the 2 holes. So what we're going to do is select one of those holes, then press shift and select the other hole. So it selects both of the holes, and we're going to select the create drilling toolpath. Make sure that you've got selected the toolpaths here, otherwise the toolpaths on the bottom right hand side won't be open. So create drilling toolpath, that opens up a new dialog box, and make sure that selected vectors is selected. Start depth of 0, and finish depth of 12, so it's going right the way through the material. Plunge clearance is set to 2. The machine save Z is 10, and also the home position. The tool, click to select, and we're going to choose a 12mm end mill for this. So just select that. In the drill center of, we want to click all selected vectors. This is because the circles are not true circles. So if we click all selected vectors for that, and we're not going to use peck drilling, so it would go down a certain depth, then retract, come back down into a deeper depth. We're just going to go straight the way through this, and the material is already set to 12mm, so I'm just going to click calculate now, and then we can close that. Go back to the 3D view, and then right click on the drilling and simulate the toolpath. And there you can see that that's drilled our 2 holes through the wood. Finally, what we're going to do is create the profile toolpath. So if we go back to the 2D view, you can turn off the drilling and the V-bit carving toolpaths if you wish. Just use the light bulbs to turn those on or off. And I'm just going to zoom out a little so we can see the whole of the outside profile. And I'm just going to select the outside profile so that all turns magenta. And we're going to create a profile toolpath. So make sure that Toolpaths is selected, and then select create profile toolpath. Make sure that the profile is set to outside because we want to cut on the outside of this particular vector, and selected vectors. Not going to use any allowance or final pass thickness or final pass allowance. The start depth is 0, and the finish depth is going to go right through the material, so that's 12. Tolerance is fine. The profiling tool, I'm going to use a 6mm end mill for this, so click select. Now if I wanted to change the tool's parameters, just click this arrow here, and that opens up all of the parameters for this particular tool. Now as you can see, the step down is only 2.5mm. I'm going to change that to 12mm, so it cuts all of this part out in one pass. And I'm going to close the parameters for the tool. And I'm going to add a lead in and lead out for this, so the cutter doesn't just plunge straight down. The cutter could gouge in a little bit on there. So what I'm going to do is add lead in and lead out moves. Now I'm going to use a linear lead in and lead out. The angle in is going to be 45 and the angle out 45, so quite basic really. And I'm going to set the distance to 15mm. And I'm just going to come down, make sure the material thickness is 12mm, and I'm going to click calculate now. So if I just zoom in at the top here, you can see that there is the lead in, then it's going round, and then it's doing a lead out at 45 degrees. So if I zoom back out, now because if I just edit this toolpath, and take a look down here, because I've got automatic positioning selected, what this will do, it will automatically put the lead in and lead out on the longest span of the profile. So there you can see that that's put that there because ArtCAM believes that that is the longest span for this particular profile. So I'll just close that. I'm going to go to the 3D view, and just let you take a look at the lead in and lead out. So there you can see it's leading in, going round the part, and then leading out, and then lifting up out of the job. So I'm going to add some bridges to this so it stays within the material. So the way that we do that is if we select the profile here, and just select the plus sign next to the profile, which opens up that profile tree. Now if I select the 6mm end mill, you can see down the bottom below the splitter bar, bottom right, you can see that it's opened up a few parameters for me. What I can do is select here for profile options, and this allows me to add bridges to my profile. So I'm going to change this to, let's say, 4 bridges. I'm not going to put the first bridge on the start point. I'm going to create 3D bridges, and I'm going to change the sizes for these bridges. So I'm going to have them 12mm in length and just 1mm thickness there, and I'm going to select create bridges. So there you can see, just zoom in, you can see it's created 4 bridges for me. Now these are in some really awkward positions, these particular bridges. As you can see, be a little bit of a pain to sand off where I've broke this from the material. So what I need to do is just move these around. So what I'm going to do is just, let's say, zoom in on the top right. Make sure that I select within this circle here, so I get a different cursor there, and then I can just left click and drag the mouse and drag the bridge to where I want it to be. So I can do that for all 4 parts. Just move this one in. So ideally I would want these to be on flat edges. So there you can see that that's moved the 4 bridges around. When I'm happy with that, just press escape on the keyboard and that will exit the profile options. So now what I'm going to do is just simulate the profile. So if I go back to the 3D view, just zoom out so you can see, and if I wish to, I can just click on the minus there so it closes the tree for the profile. Right click and simulate the toolpath. And there you can see my finished sawmill with my 3D bridges here. Now if I wanted to save all of these toolpaths to send to my CNC, what I need to do is to click on the toolpaths and then select here for save toolpaths. Now you'll see all of the toolpaths that I've used are in the right hand side here for toolpaths to save. So we've got 3 of the area clearances for each tool. Got the beveled carving or the prismatic letters, got the V-bit carving, then we got some drilling, and we got the final cutout pass, which is the profile. Now if I want to post these or generate the Gcode, what I'm going to do is just rename the file name to sawmill, and I'm going to click browse, and I'm going to just do this onto my desktop and click open. So there you can see it's now changed from, originally it was spool, and now it's saved in C users LEA desktop. Now once you've done this, you will have this favourite saved within this drop down menu, so you don't need to keep on browsing. Now if you wanted to save, let's say for instance, just one of these toolpaths, what you can do is, you see how I click that button there, that moves all of the toolpaths back over onto the left hand side of the screen for the calculated toolpaths. Now if I just wanted to save, let's say for instance, the roughing for the area clearance, just select that and then move that over onto the right hand side there. And then what I can do is, let's say that we've got the file name sawmill, I'll just change it just for this example to sawmill area 01, let's say, and just select your post processor from the list here, from the drop down. ArtCAM has over 200 posts available to it, so more than likely your machine will be on here. I'm going to just use the generic Gcode, and I'm just going to click save. So that's saved just that one particular toolpath there onto my desktop. Now if I wanted to do all of these toolpaths at once, what I can do is I'm just going to change that back to sawmill, and I'm just going to move each of these toolpaths back over onto the right hand side. Now this is what I would probably do to start with. I just wanted to show you how to do one at a time. And I'm going to click Save Toolpaths to separate files. And then if I click Save, what this has actually done is saved a Gcode file for each of these particular toolpaths. So I will have 7 different Gcode files on my desktop that are ready to be sent to my machine.